Hello, Trig class. For those who wish to look at this review session, I want to also review test preparation. We want to be totally sure that you are fully nourished, so I brought out my berry bowl. Don't they look good? So this is to remind you to eat nutritiously, especially tomorrow morning, but you can start tonight. Yum. Let's get a good picture of these. Yum. Now I want to make very sure that you're ready for this test. All right, here you need to have your your fluids. So I'm even going to throw in some chia seeds. So here they are, all milled for better absorption, of course. And by the way, I've never tried these before, in water that is. So, Mickey Mouse is standing by to stop me, but I'm not going to let it happen. I'm going to let those sit and I'll try those at the end. Alright, and then also, I want you to get good sleep. Does this pillow inspire you? This fluffy pillow? Okay. Make sure you get good sleep. Do not clean your room at 2 in the morning. Do not worry about grumpy driving instructors and other things that cross your mind. And of course, know your math. Here's a little page I put together of the things that you need to know coming into the test. They will not be provided for you. So you need to know secant is the flip of sine, and cosecant is the flip of sine, and secant is the flip of cosine. That will help you with your graphs. Tangent is sine over cosine, and cotangent is cosine over sine. And then there's this mess where you have a function with a trig. I said sine, but it can be any basic trig function. So we have amplitude in the first position, period by this key, left, right, opposite sign, and up, down. All right, let's do a couple. What I'll do is I'll show you the questions and give you what you can do. I want you to be able to graph all the basic trig functions. Tonight, let's practice these 3. So what you can do is stop the video, write down these 3, and go try to graph them, and I will show you the answers. So you can pause, do those 3, and then come back and look at the answers. The first one, is this the basic cosine curve? Come back to me. Okay. The basic cosine curve. You need to know that it has a value. Where'd my pencil go? Pencil. Let me go find a pencil while you observe the beauty of the cosine curve. Alright, notice that you have to tell me it goes up to 1 and down to -1. And these important parts, notice it starts high and ends high. Alright, so you should be good at cosine by now. Alright, number 2 was cotangent. So the cotangent curve, you want to first graph the sine curve. So the sine curve is related to the cotangent because cotangent equals cosine over sine. So this is where we're going to get the asymptotes. This can never be 0, or we are dividing by 0. So that's not allowed. So we're going to take the basic sine curve, and wherever it crosses the 0, wherever it is a 0, where it crosses the x-axis, it becomes asymptotic to the cotangent. And if you recall, the cotangent are the backward snakes. So if the snake was going in the grass, it'd be going to the left, moving that way, so he's backwards. So the cotangent is the backward snakes. So notice you must mark the asymptotes. Now let me time this. I already blabbed for about 5 minutes, I guess. So keep an eye on the timer. All right, now the third one was y equals secant x. So to graph that, you need to graph first the cosine, because secant is the flip of cosine, so it equals 1 over cosine. So when we graph that one, here is my cosine, regular cosine. So where it zeroes out, I put in my asymptotes. I make sure they're labeled, and I know that the cosine goes up to 1 and starts high and ends high. So that it goes up to 1 and down to -1. And so the secant graph is the u's. So we're going to since they're reciprocals of each other, we're just going to reflect that in this way. So this mountaintop becomes the valley of the u. This valley flips and becomes the mountain of the u mountain. And this mountain becomes a valley. So the darkened shape is your secant curve. All right, the next set will be these four. So if not four, three, four, starting with number 4. These are transformations of trig functions. So if you would jot those down and go try them on your lonesome, and if you would then turn the video back on, you'll see how these are completed. So number 4, starting with the cotangent, that is one of the backwards snake, I call it, and it's going to be moved. This will move it always opposite of what you think. So you would think a plus would go to the right. It does not. It'll move it minus pi radians. So I'm going to come up with the curve that I want to graph is related to cotangent, because cotangent is cosine over sine. So I'm interested in the sine curve, and I'm going to take the same parameters and just change cotangent to sine and graph that first. So you can see in pencil here, I started that curve. It is a regular, the one in pencil is a regular old sine curve, but I have to move it, and I got to move it back or to the left pi radians. So I took this spot and moved it back pi. I put a little x there, and this one went back, this one went back, this one went boop boop back, and this one went, where'd it go, boom boom back. So the little x's, I took the red and combined and connected all the x's, and that is my sine of x plus pi. I need that to get the asymptotes. So wherever that crosses the x-axis, there's a 0, and that's my asymptotes. So now down below, I borrowed those asymptotes. Come back to me. Oh no, I hit some weird button called capture. Let's see what that did. Alright, hopefully it's back online. If not, I will correct that. So I hit some kind of capture button. Let us notice the negative pi, 0, pi, and 2 pi. You don't have to put all of them in, but a couple, at least 2. And remember, cotangent is the backwards snake. Alright, so that was number 4. Number 5 is y equals 4 secant pi x. Let me see where I put that one. Alright. To graph y equals secant of pi x, first of all, I'm going to graph the close cousin, and that's secant. Because secant x is 1 over cosine, I'm going to replace the secant with cosine, include the other parameters, and I recognize there's a b switch here. So I'm going to figure out what the new period is. B equals 2 pi over the period is the key, and pi is my b. So solving that for period, I get a period of 2. So over here on the top sketch, I drew in the cosine with a period of 2, mountaintop, and the 4 is the amplitude. So it goes up 4 and down 4, and it will do its whole cycle within 2 radians. So mountaintop to mountaintop, 2 radians. So that's where I get my asymptotes. Notice they fell at 1/2 and 3/2. So I go down below and I draw in. I could have done it right up here on this graph, but I wanted to show you the development. So I redrew that exact graph here, and this is at the point 4, and this is at the point -4, and the red U's will complete the graph of the secant curve. Alright, and this number 6 looked like this. Just a regular cosine curve, which had another b change, which has to do with period. 1/2 equals 2 pi divided by the period. And solving that, I get p equals 4 pi. That's where the 4 pi came in. This penciled one is my regular cosine with a period of 4 pi and an amplitude of 2, up 2, down 2. The red is marked because I dropped all the key points 1 down. So this one came to here, this key point went down 1, this key point down, down, down. So I connected those with the red. That was number 6. Alright, number 7, 8, and 9 are some inverse trig. And that is not a graph, it's just asking you to find these numbers. So you may pause and try those. I'm going to go right on to the solutions. So the first solution, I used the unit circle, I sketched it, and I'm looking in the first or the second quadrant. That's for the cosine. The inverse cosine is found there. And since it's negative, it must be in the second quadrant, because everything's positive in the first. So I found this point was back 1/2, negative 1/2, and up square root of 3 over 2. So I was interested in this one because the first coordinate is the cosine. So there it is. So now I need to know the value of that. So I count by sixth, 1/6 pi, 2/6 pi, 3/6 pi, 4/6 pi, which reduces to 2 pi over 3. That's all I'm looking for, that answer right there. All right, number 7, tan inverse of 0. I drew this. I'm looking in quadrants 1 and 4 for inverse tan. So 1 is going to, it could be this, this, or this. Tangent, we look for the second coordinate divided by the first. But this would cause a division by 0. So with this one, so we have 0 divided by 1 is 0. So that must be the answer. What angle is that? That is at 0 radians. So the answer is 0. Don't use 2 pi radians, it's equivalent, but don't use it. Sine inverse of negative square root of 2 over 2. I can look for inverse sine at quadrant 1 and quadrant 4. It's quadrant 1, quadrant 4 for all those in my physics class. Alright, so we have, this was a point of interest, and I look down here. Because it's negative, it's going to be in this quadrant. So I'm going to notice this point was over square root of 2 over 2 and down square root of 2 over 2. And that means the second coordinate is what I need, so I need to know the value of this angle. So I could go around 1/4 pi, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4 pi, and get 7 pi over 4, or I could cause the better answer to this is negative pi over 4. So that's that. The last one that we're going to talk about is the dampened or damped, I've heard it called both, trig function. So on this one, we're looking at y equals 1/3 x sine x. So pause and graph, turn it back on, and here we are with the answer. This is the part of the function that causes the boundaries. It will be y equals 1/3 x and y equals negative 1/3 x. So when I graph y equals 1/3 x, it's a straight line. It crosses at the origin and has a